Well, hello, thank you for joining us. We're going to be presenting the CME department. CME, those letters stand for computers, math, and engineering. Our department has 4 areas of study: computer science, engineering, data analytics, and mathematics. And we actually have 4 professors here today to discuss each of these areas. We're a large department. This is the list of our professors. You can see we have professors in engineering, math, data, and computers. Despite being such a large department, we're part of a small college. So you get advantages of both. There's a lot of options for study, but you're in a cozy learning environment. This room that's shown here is actually our largest classroom. It holds 27 students. So that's about the biggest class you'll have, and you'll have that when you're a freshman. In later years, it's probably more like 10 to 20 students in a class. The advantage of being in a small classroom is you get to know each other, you get to know the professor, and the professor gets to know you. I went to a university that had 40,000 students. I don't think any of my professors knew my name. I don't think they would know who I am. But I know the students who are in this picture, and because it's a nice small learning environment, you'll be encouraged to talk and to participate. And hiding out in the back and hiding your head and hoping you don't get called on doesn't work at Shepherd, because we can see you and we'll call on you and make sure you're involved. And if you're not showing up to class, we'll probably send you a note and ask what's going on. I wanted to take a moment to mention that we're in hard times right now, and we've transitioned to online classes for the most part in our department. This was in response to the pandemic. And over the summer, all of the faculty in our department were trained and certified for online education. What's shown on this slide is an example of a learning module in a computer class where the student can find the slides, a recorded lecture by the professor, as well as the homework and quizzes at the bottom. In the middle, you can see that there is a plan for in-class meeting. So students attend by Zoom and write a computer program together. Well, I promised we would focus on each of the 4 areas. So let's start with computers. I'm one of the professors of computer science, and my research area is called bioinformatics. It's the study of applying computers to problems of biology. One of my publications is shown here. It's where I got to use a lot of the software that I developed to explore a cell line that's used for scientific research. Not very important what was going on biologically, but I was very excited to be able to make a dent in science using my software. Another interest of mine is the infrastructure on campus. So I have a grant from the National Science Foundation to plan for infrastructure of the future for our campus. So we're looking at our networks, our bandwidth, and what we could be doing a few years down the road. Yet another interest of mine is machine learning. What I'm showing here is a figure from a paper that I hope to publish soon, where I'm training a model to learn something about RNA. And at the top left is a very good learner on an easy problem. And the red line reached high. it scored well. At the bottom right is a poor learner working on a tough problem. And you can see it doesn't learn very much. The learning curve is flat. So not only do I work on educating students, I work on educating software. This is software that is not programmed to know anything about RNA. It's programmed to know how to learn. That's what machine learning algorithms do. In our department, we have majors under the heading of CIS, Computer Information Science. These are some of the majors that you could choose from: computer science, cybersecurity, computer programming and information systems. Each of these majors has concentrations within it. You'd be able to specialize in some aspect of that major. These are comprehensive majors. That word means that a minor is not required. You could do a minor, but you don't have to do a minor. You can, just studying this major is enough to get your degree. In addition to CIS, we have CIT majors, Computer Information Technology. These majors are more focused on systems, less on the math, and there's majors in information technology and MIS. So these majors will concentrate on servers, networks, cybersecurity, decision support. At this point, I'm going to pass the buck to my colleague, Dr. Mills.
All right, Professor Miller, thanks so much, and greetings, everyone. Welcome. I'm going to talk for a couple of minutes about our relatively new, it's been around for a few years, but growing data analytics program. We have approximately 20 students, and we offer both the bachelor's and master's degree in data analytics. So my background is in applied algebra and cryptography, but I also have a background as well with doing research in applied math. So when the opportunity came up last year to take over the data science program, I found myself in a unique position, and I was happy to come on board not only as an assistant professor of mathematics, but also as the data science program coordinator. So Jason, if you could advance this, you can see here, my research interests again are in mathematics of secure communications, in cryptography, and so forth, but I also have interests as well in various branches of applied mathematics. So again, I'm in a position to be able to help our data students, not only with the mathematics, but also in its application. And again, if you could advance the slide, please. As I mentioned, we have both a bachelor's program and a master's program. So let me talk about, first of all, the bachelor's program, and it'll lead in to what we offer as well at a graduate level. I had mentioned beforehand that I'm prepared to help people out who are studying data analytics from a mathematical standpoint, and that's true. Our data analytics program is a bridge program in that those who major in data analytics are going to do a lot of math and are going to learn a lot of math, but they're also going to have one foot in the computer world as well. And so they're going to be seeing a lot of Professor Miller and the others over in the computer science realm. We start off at the freshman level by giving students a flavor of what data science is all about, again, both from a mathematical and a computational standpoint. And then what happens is that if you're a data science major, you're going to be taking a lot of math courses because you have to have that strong mathematical foundation in order to be able to, when you go out in the real world and you get that job working with big data, you need to be able to work with models and develop models of your own, mathematical models that not only describe the situation in front of you, but accurately predict what you think should happen next. So as I said, you're going to end up having a lot of math courses in calculus, linear algebra, statistics, probability, the whole gamut. And then what will happen from there is that you're going to, in your senior year, you'll end up taking a course called Big Data Analytics. So you're going to learn the mathematics behind how to deal with massive amounts of data, millions and millions of data points, how to be able to approach a problem, not be overwhelmed by it, be able to, from an algorithmic standpoint, from a computational standpoint, be able to handle these problems and make your employers very happy in the end. As far as our Master of Science program, there are two tracks for that. Of course, we've got the Master's of Science program for those who who already have a bachelor's in hand, maybe in data science, maybe in another area, and they're coming back. They're already in the real world, so to speak, doing jobs, and they're coming back for continuing education. But we also have a 5-year degree, as noted here in the slide, or our 4+1 program. And that means if you're a data science major and you're doing very well, you have a GPA of at least 3.0 after your first 2 years, you can transition into the 4+1 program, which means that in your junior and senior years, you can start taking graduate level data analytics courses and have that count as graduate credits, so that by the time you're done with the first 4 years and you have your bachelor's in hand, you don't have to go another 2 years just to get the master's. You already have taken several courses, you're already halfway home to a master's, and you only have to be around for 1 more year, take the rest of your courses, and present your capstone work. Maybe you'll do an internship. We have a lot of people who like to do internships as well with companies around the area. And you present your work, and we give you the thumbs up, and you get your not only bachelor's degree, but master's degree, and you're able to move on to a job, hopefully, that you'll really like. All right, Professor Miller?
I'll pass the baton to Dr. Karen Adams.
Thank you, Jason. I'm Karen Adams, and first I want to commend you for considering Shepherd. I think a state university school really is the best buy as far as your education goes. Just a little bit of history. I actually attended Shepherd College and earned a Bachelor of Science in Mathematics at Shepherd College. I taught somewhere else for about 15 years, and I returned back to Shepherd University to teach here about 10 years ago, mainly because the mathematics department here was integrated into the engineering and the computer sciences, and I really think that that's a good thing for students. So a little bit about the mathematics degree. We have a Bachelor of Science in Mathematics degree. Oh, okay, I can talk a little bit about, there we go, thank you. We offer a comprehensive degree in mathematics with 2 concentrations, traditional mathematics, which you'll take the advanced calculus classes, the upper level algebra classes, you'll take some non-Euclidean geometry, and it really prepares you for graduate school if you intend to do that route. We have some applied mathematics concentrations. Right now, we offer an industrial mathematics, but starting in the fall of 2021, we're going to be offering a concentration in actuary sciences. So that might be something that you're thinking of, and that's a statistical kind of concentration there. So again, as Dr. Miller mentioned earlier, there's no minor that's required. We really focus on brimming, the major is brimming full of mathematics courses of your choice. So we have about 20 students in the program right now. I know every single one of them by their name. And they're very good students, and they do a lot of activities together. A lot of them are in either some of the computer science classes together, because we do require some engineering courses in the degree. So they get to know the students in the engineering courses, and they also get to know the students in the data classes. Often the students will take a couple of the introductory level data classes too. I strongly recommend that they get some of the applied mathematics as electives as they pass through there. So next slide, please, Jason. I think.
Do we going to go back one?
Okay, we can. I talked a little bit about myself again. My research is actually in pure mathematics, but interestingly enough, I did teach high school for 6 years, about 30 years ago. And so I'm involved a little bit with some of the students who might be interested in mathematics education. Usually our students who are in mathematics majors might be also interested in getting a certification in education. And so I do advise those students so that they can fulfill both degree requirements. But generally speaking, my research is in pure math at this point in time. So Dr. Wang is also one of our mathematicians, and she's doing she does some biological modeling. She's more of an applied mathematician, but she teaches a lot of the courses in calculus and differential equations for us. But she's been here for quite a while. Students really enjoy her classes. And I think what I'll do now is I'm going to introduce our our chair, Professor Reza Mirdamati. He is in charge of all of us, keeps this large department moving forward in very positive ways. So he can talk a little bit more about the engineering programs. He's hiding under the auspice of Dr. Miller's name over there.
There we go. My name is Reza Mirdamadi, and I'm the fellow in the middle. And you want to go back up a little bit, Jason, talk about engineering. Yeah, I'm also serving as the chair of a department. And I want to say that you are in a good hands. This department is very, very diverse in terms of mathematics, computer science, and engineering. So that's why we are able to offer all these 6 majors in one department. So if there is an apprehension about what department, what major you want to be choosing, there should not be, because for the most part, at least the first year, most classes are going to be composed from mathematics, physics, and these are the courses that everybody's going to be taking. So we are offering a 4-year engineering program that our university is small, so we only offering two 4-year program in engineering. One is a computer engineering, the other one is engineering science. Computer engineering, it's the way that we offer computer engineering at Shepherd is 50% hardware and 50% software. So the students and the engineers that are designing this hardware, they must have some background in programming as well, in order to make sure that these hardware that they're designing is functioning the way they should. So so that's our engineering, computer engineering. And we also have, let me talk about engineering science. Engineering science has 2 concentrations. One is environmental engineering, which you can imagine any aspect of life, any project inside the government or private industry, the very first thing you have to look at is the environmental impact. And the other concentration of engineering science is systems engineering, which back in early days, in 90s, used to be called programming engineering, or something that we had to do with the making sure that the system, that any concept of engineering is functional in a sense that it's efficient. And yeah, it used to be called manufacturing engineering. The word has slipped on my. So there are 2 concentrations: environmental and systems engineering. And I must say that both of these engineering, the kids have to do a capstone class. Our capstone class is a 1-year project. You start with the concept in the first semester, and you finish up the concept by the second semester. And if you go back, Jason, go back to the Ching Wang's slide. And one thing that we all do, this is just one example. This is just one example out of all of us. One thing that we all do is we do research with the students. All of the faculty that you see here on the screen, they have some projects that they do with the students. And they are part of a NASA consortium, West Virginia NASA consortium, and the students get paid doing research with faculty. Dr. Wang has about 6 students working with her on a grant that she has. And of course, some of them are paid by the NASA grant. And all of us here, Dr. Adams, Dr. Mills, and our friend, Professor Miller, who is doing this, sharing a screen with us, they all had the students working in a research that they were supported by grant or by NASA. And So, and also one thing that we also offer is a dual degree program. So if you're a computer engineer and you want to be a computer science as well, there are some opportunities. So here we go, dual majors. Thanks. So for example, if you want to be graduating from Shepherd, you need 120 credits to graduate. A dual degree is going to be about 135, 136 credits, and that would translate to one more semester, and you have a dual degree in computer engineering and mathematics, or computer engineering and computer science, or mathematics or system engineering and mathematics and data analysis, and of course, mathematics and computer science. The point is, by the time you finish your math degree, or by the time you finish your computer science degree, you are taking so many of these classes in different departments, so you might as well entertain a dual majors. Something about the robotics I should mention, Jason? Yeah, this is the robotics lab. You had a picture of it. So this is a robotics lab that is cleaned up for taking the pictures. So we ask the kids to clean up the lab. They're gonna take the pictures. Usually it's not that clean. So we make our own robots. It's not putting kits together. We have 2 3D printers that the students have access to this lab. They make their own parts, and we buy the sensors, we put them together, and we have competitions every year, and the schools from all over the country actually come and compete with us during our RoboFest, Shep RoboFest that we call it. So we had colleges from Harvard, from West Virginia University, from Penn State, from Clemson, not Clemson, did I say? Yeah, Clemson. And we had the students from Stony Brook. They all participated in our competitions. So they come from all over the place. Did I miss anything?
I think you did a great job talking about our engineering majors and our robotics program and the dual majors, people who can't decide, I suppose,
Yeah.
and want to do it all. So we want to encourage you to come to Shepherd and challenge yourself to be great. We have students who've done great things while they're at college. We try hard to send our gifted students off to competitions, to learning events, to conferences, and some of them surprise us with wonderful posters or projects of their own creation.
Actually, one more thing, those 2 students were supported by the CME department to go to Italy to, it was a 3 weeks academy that they were supported by the department to go and compete in a European Innovation Academy. There were 170, I'm sorry, there were students from 78 countries that they participated, and we for past 3 years, we sent 2 students every year. So
yeah, and another thing on this slide is the Major League Hackathons. I personally take students to the Major League Hackathons, and we get to compete against teams at other schools in writing a piece of software or controlling some hardware, whatever the project is. At the hackathon, we get our project and we have 2 days to work on it. It's a very exciting event. We as faculty try to provide plenty of opportunities for our students. So we have grants that allow students to do research and get paid for it. We also have programs that we just attend for free, going to competitions as often as we can. We'll organize a school van in pre-COVID times and all go together and compete. We try to bring in scholarships. So in addition to the scholarships that are available to the whole school, we do have some scholarships within our department. Please contact us if you're interested in these. And overall, I'd like to say we're looking forward to seeing you at Shepherd. Thank you very much.